Welcome to BriForum. I'm just curious, I can ask this in most of my sessions. Who's been to BriForum before? Wow. Who's never been to BriForum before? Who didn't put the hand up? No. It's been my privilege to speak at a number of BriForums now. So I think it's my 6th or 7th time. They keep asking me back. They probably don't watch the videos, that's why. I love BriForum. I love it for the community feel and for the independent technical people who come along and speak and give their time. I love going to everybody else's sessions. It's great. And I hope that you guys are enjoying it as much as I usually do as well. All right. Storage improvements in vSphere 5.1 to help with your desktop virtualization project. It's a pretty exciting, snappy title. This might not run the full 75 minutes, guys, because once I run out of features, I'm going to run out of features, So it's not going to go on beyond that. So we'll just see how and when we finish, but we may not run, as I say, the full 75 minutes. We have Dave Stafford here, who's also a presenter, who's going to kick me if I get anything wrong, which is good. So we've got sort of two brains here. So who am I? I'm Jim Moyle. I live in London, just down the road, which is handy. It's handier than Chicago is, anyway. You can find me on Twitter at Jim Moyle. Oh, that's good. I've got a typo in my own Twitter address. That's a really good start. I could pretend that my middle name is Michael or something, shall I, for that? And I've got a blog at jimmoyle.com. I work for one of the sponsors here, Atlantis Computing. And we sell software to help with storage and desktop virtualization, which is why I'm interested in storage and desktop virtualization, because it's my job. And a lot of my BriForum presentations have been around IOPS and Windows 7 and how that works with storage. So we can talk about that a little bit as well. Well, we will talk about that a little bit. And if you want to have a chat with me, I'll probably be on the stand if they make me. Otherwise, I'll try and avoid it. I'm also been lucky enough to be a CTP for around 18 months. There's quite a few of us here today. I think they must be giving away CTPs like with a go-to-meeting license, I don't know. But yeah, there's a few of us around today. Given that I'm a CTP, I'm going to be talking quite a bit about Vue today and vSphere. So it's a bit of a VMware-centric presentation today. The reason being is because if we're going to talk about advanced features in vSphere and new features in vSphere, then obviously Vue is going to take advantage of them first. There is stuff that Citrix will be able to take advantage of because it's just API driven, and we'll kind of cover those stuff as we go through it. But yeah, to start with, we're going to be fairly Vue-centric. So I know BriForum's always kind of considered to be a bit of a Citrix-centric rather than a Citrix and VMware conference. So who's installed Vue before? Okay. And who has never touched it? Okay. Thank you, Kenneth. Who is the Zen Desktop product manager? Why do we need storage enhancements in the hypervisor? Well, it's kind of the control area. We're not getting performance from or capacity from the hypervisor, but everything's passing through it. So it is the control layer for storage. So that means that we can do clever stuff in the control layer. It means that we can do interesting stuff around prioritization of IOs. We can do interesting stuff with integration with different storage vendors. So I think that storage enhancements in the hypervisor and storage enhancements on the front of the SAN are going to become one and the same. I mean, you see that VMware's bringing out a vFlash feature eventually, and that integrates with stuff on host. And you find a lot of these storage features are moving closer to the hypervisor. For instance, Zen Server, did you hear me say it there, Ken? Zen Server has IntelliCache, yes. Storage feature moving into the hypervisor. Whether these storage features are provided by the SAN vendors or by the hypervisor vendors is a bit tricky at the moment. There's kind of a bit of a clash there as to who's doing what. But yes, there's going to be more and more storage stuff moves on host. Whether it's local flash, whether it's software features, whether it's control features, but yes, lots and lots of stuff on host. Specifically, what are a couple of problems with VDI? Well, this is one. The early bird is a problem with VDI. If you have some kind of centralized storage for VDI, then, which a lot of people do, right? Then say you've provided, let's pick a number out the air, 20 IOPS for a user, and you've got 1,000 users, you've got 20,000 IOPS on your SAN. All sounds fine, right? Guy comes in at 7 o'clock in the morning, he's got 20,000 IOPS. He's a happy bunny. 2 o'clock in the afternoon, he's got 20 IOPS. Not quite so happy. So consistency of user experience is really important. Because users are fine with anything as long as it's the same in the morning, the afternoon, on a Monday, on a Friday. Yeah. I've been into some places where they have a terrible user experience on VDI, but it doesn't result in support tickets because it's been the same forever. Nobody bothers anymore. Users can get used to anything as long as it's consistent. If you provide an inconsistent user experience, you're going to have problems. So early bird is a problem if you've got shared storage. Noisy neighbor is a big problem because noisy neighbor means that one person can be taking a lot of I/O and stealing everybody else's. So Windows itself has absolutely no concept of fair use or quality of service. It assumes it has 100% access to whatever storage it has. So that means that it tries to do exactly the right thing. Yeah? It tries to use the resource it has access to give the best possible user experience. Excellent, well done, Windows. The trouble is when you do that in a shared environment, you're stealing from everybody else around you because you don't have infinite resources, right? Now, hypervisors have very good mechanisms for splitting out CPU and memory resources. In fact, that's what a hypervisor is based on, is fair share of CPU time. Doesn't have very good, or haven't had very good features for ensuring quality service on the storage side. So early bird and noisy neighbors are two big problems when you've got Windows and centralized storage. I like a graph. There's not too many in this one, but tomorrow's one, there's loads of graphs. This is a physical environment. This is not a virtualized environment. This is 1,000 concurrent users on Windows XP, and it's a government department. This is the total I/O demand from those 1,000 users on physical XP boxes for a day. And we start at 7 a.m. and we finish at 7 p.m. There is no log-on storm here because this is a government department. They have flexible working. So there's no log-on storm. And what we can see is as more and more people log on and as they're using their devices. Now, this is absolutely classic trace, right? This is a lunchtime log-on storm here. And you get your peak use somewhere in the afternoon. This is because it's default user behavior. What people do is they come in and they open Outlook, and then they open a few tabs, and then they open a few more applications. And you get this gradual build of load over the day. And then, of course, they start logging off, and it goes back down. Now, remember, each one of these people is limited to a single spindle. So there is a limit to how much this burst can go up. So this is going to be pretty similar to everybody's VDI environment, apart from, like I say, they'll have a log on Storm if everybody starts at 9. So what this means is you can see very easily how this early bird problem, right? Because if you transfer this into a virtual world, so what's the peak? The peak is about 47,000. Interestingly, the average, the mean of this data is 6,000 IOPS. 6,000 IOPS average Windows XP. You see that a lot around, don't you? 6 IOPS average Windows XP. Steady state. So that's about there. So if I size on average, which a lot of people do, yeah, because they think it evens out. Yeah, if I size an average at 6 IOPS for 1,000 users, and I provide a SAN with 6,000 IOPS, can anybody see a problem with this picture? Yeah? All right. So I hate sizing on average, honestly. I mean, it applies equally well to CPU, memory, any resources, network especially. So let's say we size it something more sensible, like 20,000. So 20,000 is the number I said before about your single user who comes in the morning, he's got 20,000 IOPS. He's a very, very happy man. Yeah. So Windows will burst very high. Yeah. So it's enabling burst capacity. But people over here, yeah, he's got no burst capacity. It means that he's a very sad man. So what we want to try and even out the user experience. We'll bring this back to the vSphere stuff but you know, let's talk about what the problem is to start with. So this is Perfon. Perfon, we're measuring IOPS in a single Windows 7 VM. This Windows 7 VM has access to about 40,000 IOPS because it's running on one of our Ilio virtual appliances. So essentially, it's got as much burst capacity as it wants. And what's happening here? So the scale goes up to 5,000 there. Yep. 0 to 5,000, time along the x-axis. And what we've done is just use a script to open up a bunch of applications. So Excel is peaking at about 3,700 IOPS there. Windows Update is about 4,000 IOPS. Again, this is Windows doing the right thing for its user. Yeah, it's using the resources it's got access to provide a good user experience. If you've got an SSD local to your laptop like I have here, yeah, the reason why your user experience is great is because you're allowing these peaks. Windows is not frivolous with I/O. Opening Excel will take that many reads and writes. Yeah? If your limit is down here, yeah, it just squashes the whole thing down, and you add time. Right? So instead of taking 1 second to open, Excel will take 30 seconds to open. It will still do the same amount of reads and writes. So essentially, user experience is dependent on burst capacity. And we'll talk about that as well. Yeah, I wouldn't actually allow anybody. If I change jobs and somebody says, here's a laptop, and I say, is there an SSD in it? And said, no, I said, go away. Go, find me one with one in. Because it makes that much of a difference allowing burst capacity. So how does vSphere help with this? Well, like I said before, it's middleware, essentially, for storage and the Windows OS. And it can act as a control layer. So there is all kinds of stuff, and we'll go into it a little bit further on. Now, VMFS, it was creaking a bit. It was quite old. VMware wrote it quite a long time ago. And one of the things they've done recently is upgrade it. And we'll talk about that in a second. But first, I want to talk about this man here. This man is called Cormac Hogan. He's the storage evangelist for VMware. He's amazing. He's helped me out a lot with this presentation. So I just want to give him credit. He's a very, very helpful man. So if you want to find his stuff, He tweets at VMware Storage, and he's got a blog at cormachogan.com. So all of the stuff that I talk about today, he goes into a lot of detail on his site and on his blog. So excellent resource if you want to know a bit more about vSphere and storage. So you know I said they upgraded VMFS recently. Well, I went from VMS3 to VMS5. I'm going to try and make sure that this is tied a bit more to desktop virtualization rather than to just vSphere. So some of this stuff we'll not talk about at all. The one I really like, though, is this unified block size at 1 meg. It's much more efficient at writing data when you've got a smaller block size like that, because what used to happen, in order to create large 1.9 terabyte files, you had to change the block size. And it went up to 8 meg. And much more inefficient at writing. VMS5, now it's 1 meg across the board. Yeah, 1 meg across the board. Which is a nice change for efficiency and for speed, which obviously is needed for VDI. Upgrading, very easy. There you go. You can even upgrade with running VMs on your VMS3 infrastructure. The reason is because VMS5 in an upgrade path will just add metadata to your original VMS3 file allocation table, or whatever the VMware calls that. That sounds like quite a nice thing to do. I wouldn't advise it, though. There is a problem with upgrading to VMS5. And the problem is this, is that none of this is upgraded properly, right? You're much better doing a new VMS5 rather than upgrading an existing VMS3 and doing storage vMotion across. Because my file block size stays at 1, 2, 4, or 8, whatever it was before on VMS3, and you get all the other stuff. You know, it's only GP GUID partition table. If it grows beyond 2 terabyte, honestly, just start again and storage vMotion. Don't upgrade in place, because I don't want to have to troubleshoot that if you've got a problem with it. So VMS5, VMFS-5, that's great. View. Now, view, when you create view pools, you can pick where to put your replica, or your replica is your golden image. This is a very cool feature. You can split your golden image from your Delta files. Ken. MCS can't do this. View can, and it's great for quite a few reasons. One is if you are using some kind of cool storage for your VDI environment, whether you got Pure or Atlantis, or it doesn't matter, whatever it is, then essentially you've swapped what in traditional SAN is low price per gig and high price per IOP to high price per gig and a low price per IOP. So space is at a premium in some cases when you're doing VDI. And I'm saying this now just because Ken's in the room. I've had people who wouldn't use MCS purely because of this. Yeah, space is massively important. And if people have got several images and you're putting each image on each store, it becomes a large problem. But View can split it off. So you can do a central replica. They call it view storage tiering, which is a bit of a clever name for what it or whatever. This becomes actually a limiting factor. It was a limiting factor. Because if you split off your replica in this model here and have it held once and centrally rather than once per data store, VMS had a limitation, which was you could only have 8 hosts sharing a file with read. So your maximum cluster size became 8. This was limiting. So in vSphere 5, they changed it so that if you used NFS, your cluster size could be 32. And in vSphere 5.1, this has been increased to 32 for VMFS-5. Yeah, and so your scalability is now 32 hosts for your view cluster. Again, nice improvement that you don't have to do multiple clusters. It was only ever there because of that golden image thing anyway. So if you did your replicas, although they didn't say this, right? It was always just 8 is your maximum. But now 32 is your maximum, so that's a good thing. VAAI. Now this sounds, you know what I said about storage features moving into the hypervisor and hypervisor features moving into the storage, and this kind of common ground between your storage vendors and your hypervisor vendors, right? So VAAI is kind of a way to address that a little bit, to try and do a bit of cooperation between your vSphere and your SAN. So your SAN vendor writes a little module, it plugs into vSphere, and vSphere will offload the jobs that are tricky or are resource intensive to the SAN. So if a SAN can do some clever cloning, or if a SAN can do some clever stats, etc., etc. So these are all the different types of job that can be offloaded to the SAN if the SAN's got the right feature set and they've written the module for vSphere and you've configured it. This all sounds pretty cool because it takes loads of pressure off your hypervisor and gives the jobs to the SAN that the SAN's good at. And when it works, it's great. Love it. There is an issue, though, is that there isn't that many storage devices supported. And because it's on the SAN vendors to go and write their modules and stuff, I think that it's about 700 or 800 devices that is supported by VAAI, which, you know, in the whole world of storage isn't very much. And it's only sort of 6 or 7 devices per vendor, and tends to be a very small subset. You know, we're including sort of like, you know, device iterations. So this is from the VMware HCL, right? So whether it's to do with the SAN vendors not writing the modules, or whether because this is all proprietary and it'd be better if it was open standards, I don't know. But it doesn't seem to have the uptake that it should do, to be honest with you. But anyway, the one that's changed from 5 to 5.1, thin provisioning on map. Cool. So thin provisioning on map, that we care about that. So if we're thin provisioned, then we got 2 helpful things with VAAI, or rather 2 things that VAAI can do to help is outer space condition handling. So if you have overcommitted your storage by using thin provisioning, and everybody does that, let's face it, you can now get a nice warning saying that you've run out of space. And not only that, is that we can stun individual VMs, and then VMs which are not requesting extra space can then carry on. It's VDI, almost everything's thin provisioned, right? So if you're using MCS or if you're using PVS, you know, your Delta files can grow and you may run out of space, but at least only the ones that need the extra space are going to die, and the rest will keep on working, and you can hopefully do something about it. Yeah, so if a data space VMs requiring more disk space are paused, VMs not requiring any additional disk blocks continue to run. Good stuff. Dead space reclamation. So I've been thinking about this. NTFS has an issue with this, and we'll go into this in a bit as well. When blocks are no longer in use, when you have a deletion or when you have a storage vMotion, they tend to hang around. What you can do, this VAAI unmap primitive, yeah, it means that when you do a storage vMotion and your VMs have moved around, it can remove the shadow, because it will make sure it can cause proper outer space messages when really you've got loads of space left, because in fact you've got just blocks lying around. this dead space reclamation came in 5, and I think the day after GA, they found out that it was a bit broken, and they had to disable it, and now it's back. But unfortunately, it's a manual process, so it's a VMKFS tools process to run and get your storage back. But if you're in a case where you're using VAAI, and for some reason your storage is full when you don't think it should be, it's going to be this. And there is a tool you can run to get rid of to get your storage back. I'm going through my slides quite quickly here, boys. We're going to be here a very short time if you don't ask some questions. VCAI. So this is exactly the same as VAAI, but for View. I don't think Citrix will be able to take advantage of this one. So it's probably going to be a View only feature, except it's not even a View feature. It was in Tech Preview in 5.1, and it is still in Tech Preview in 5.2. I don't know what the issue is. I did ask, but they wouldn't tell me for some reason. But yeah, it doesn't appear to be moving very quickly into the production product. Essentially, though, it does exactly the same thing, as I say, for View as VAAI does for storage. So it means that you offload a lot of the operations onto the SAN, a lot of the View deployment, the cloning, the link clones, all that stuff. If the SAN's got the features, you can offload it to it. Tech Preview only, use with caution. Be nice if it makes it into the production software at some point, but there you go. Again, requires the same NAS plugin, right, from the SAN vendor. So whether it's the SAN guys or whether it's vSphere or whether it's both, I don't know. Be nice if it came along. Storage I/O control. Now, this is one that Citrix can take advantage of because it's just a general thing. I really like storage I/O control. So it means that, you know, I said that Windows has no idea of quality of service? Well, this is the hypervisor being a control layer and enabling quality of service. Because this is the noisy neighbor problem. Because if you have an app that is demanding a massive amount of I/O, then because the queue depths are the same around the hosts, it means that it can essentially starve these of I/O. So this is a real problem. Because really, you don't care about this app getting loads of I/O, and you really want consistency from the other two. So vSphere does this by mucking about with the queue depths for VMs. And essentially, what you can do is you can throttle down your noisy neighbor, so it's nice and quiet, so your VIP applications carry on as normal. This is all based on shares and latency. So it used to be that it would kick in. So if your data store had a problem, if your latency went above 30 milliseconds. This was a bit general. It didn't work for SSD because if you get an SSD drive and its latency is above 30 milliseconds, you're in serious trouble, right? Whereas a SAN, it's okay. In 5.1, they've changed this. So now it takes better account of SSDs, and the latencies are algorithmically determined rather than just set at a straight 30 milliseconds. If you have noisy neighbors, so something like an AV scan, right, will take 800,000 IOPS, or 800,000 IOs, not IOPS, yeah? That is a very, very noisy neighbor when you've got very little spare. This will help with that sort of condition. Yeah, it will throttle down your noisy neighbor, and it will enable you to your other users to carry on. Because if you got one guy that runs an AV scan, he can ruin everybody else's day. storage I/O control. So one virtual machine on one host can affect I/O performance by issuing a large number of I/O requests. Right? Desktops are particularly bad for this, right? Because they are an interactive workload. Yeah, you have people doing stuff all the time. It's not just a service running in the background. Very, very, very spiky. So extremely good that you take care of this noisy neighbor problem. So I don't know if you know when you edit settings, right? And you go into your resources tab, disk, you've got share values and you can limit the IOPS. Storage I/O control uses that mechanism to throttle back VMs. vSphere 5 introduces it for NFS-based storage as well. You tend to find that a lot of these advanced features are NFS only, not for block-based storage. A couple of years ago, it was a toss-up between NFS and block-based storage, but I'd say go NFS if you can, just because you get more features. This is really interesting here. Because with this, you can solve your early bird problem. Because what's the issue with your early bird guy? He's got access to 20,000 IOPS at 7 in the morning, and he's got access to 20 at 2 p.m. If you limit his IOPS, he cannot burst at 7 in the morning. Yes, fair enough. He's not being, you're not being as kind to him as you could be at 7 in the morning, but he's going to have a much more consistent user experience. So you can, by limiting the amount that you can burst, you can achieve consistency. But bear in mind, performance comes from burst capacity, right? So you are going to limit his performance. If you have got something like SSD solution or Atlantis, then perhaps this isn't a good move. If you've got something like a traditional SAN, then absolutely.
In a view environment, would
Yep.
you configure this on the golden image, or would you?
It's on a per VM basis.
So we're going to have persistent desktops and configure it on a persistent desktop
Yes.
basis.
Yes. So, so if you stop burst, you kill performance, but you also make it even for your users. I like having burst myself, but you haven't got a choice if you're using a traditional SAN, right? You can do some cool stuff in demos as well with customers. If somebody says, if you find yourself in a situation where somebody says, yeah, 10 IOPS per desktop is fine, you're all right, no worries, no worries. I can show you what that looks like if you like. I can limit your VM to 10 IOPS right there. 10, thank you very much. See how they like that. They will be very unhappy, yeah? And to be honest, even if you start limiting it to like 300, you still start to go, oh, this is a bit slow. Yeah, so it's an interesting experiment to make when you're in a conversation about I/O and VDI. So I like this mechanism. So shares is interesting because you can make people VIPs, yeah? So you can configure how many shares that they get. So because this storage I/O control works between hosts as well as on a host, yeah, because you can configure shares, it means that, and then they can mess about with the queue, it means that you can actually get quality service between hosts on your cluster as well. So again, not just noisy neighbor on one host, but noisy neighbor between hosts as well. So again, ensuring consistency, ensuring a good user experience.
Is there a particular update of 5.0 with this?
So, yeah, so essentially it's been an iterative process. So storage I/O control has actually been around since 4.1, I think. But it's just got better and better. So you didn't have the ability to do SSDs, you didn't have the ability to control your latency algorithmically, that sort of thing. So 5.1 brought that in. But I also thought it's probably worth going into as well, especially in reference to VDI. storage IO controller has some. So interestingly, it starts off, it's automatically on, but in stats only mode. So if you decide to turn it on, it will immediately work rather than trying to having to gather statistics. Now, what it does is it looks at, so I said it creates the latency thing algorithmically. It goes and tests everything, yeah, on a periodic basis. So it tests the performance of each of your bits of storage, and then gathers statistics about it, and then you can assign VMs according to the latency. Storage IO control should not be used for tiered storage. Why is that? Because it goes and tests the storage and then gets a value for how good that storage is. If you have tiering enabled on your SAN, that can change. The performance that VMware gets from that exact same bit of storage will change depending on where that particular bit of data is on your tier, whether it's on the front SSD or whether it's on the back 7K spindles. Do not use storage IO control on tiered storage, because you're kind of trying to do the same thing but in two places. So either the SAN does it or VMware does it. So don't use both. So this is what it does, right? So it does device modeling, yeah? There's the peak throughput of device and then peak latency value, and then threshold is then set, yeah? And you can do storage, and actually you can do storage DRS based on this. So DRS. Let's talk a little bit about DRS. Who thinks DRS is useful for VDI? Nobody. Good, thank God. I hate DRS in VDI. Because the desktop workload is so bursty, yeah? If you open an application, yeah, let's see. So if we get perf1 up, right? Transfers per second, 2,000 IOPS there, yeah? We're rattling along at 12 IOPS. It's all fine. And then let's open an application, right? Right. So I'm bursting up to whatever. And as soon as my application's open, this will go back down to almost 0. You can do this yourself, right? It's easy. Just open perf1 on an SSD-based Windows. So that's bursting up to what, 600, 700 there. And then it goes quiet. So it's the same for CPU and memory, very, very bursty. DRS assumes that VMs have got a static demand, or at least demand that's not quite as variable as this. And as it starts moving VMs around, by the time it's moved it, the demand for that VM has for resources is completely changed. So I don't like it doing DRS in VDI. But you will find VMware white papers, you will find VMware documentation that says it's best practice. You will also find VMware documentation which says do not turn it on. Quite often, I will speak to customers and they say, no, here's the paper with a VMware stamp on it that says DRS is best practice. I have to turn it on, so fine, okay? I'm not going to argue. But really, I don't like it for VDI. And storage DRS is the same, right? It's too bursty. Now, there is maybe an exception to this, as if you're doing persistent VDI, and you've got stuff like developers who might have a more constant demand, and you want to move them around. That's fair enough. But I wouldn't say that there's a big use case for it otherwise. It works really well, though, especially for servers. So I really like storage DRS, but just not for VDI. It overcomplicates things, and just put your VMs where they land, it's fine. One thing that it would be nice for with Vue, though, is when they do recompose, it only takes the CPU and memory stats of a host as to where to put that VM on the cluster. Doesn't take any account of storage at all. So you can end up with a single bit of storage which is overburdened just because it's only taking account of CPU and memory. If they tie in the stats that they get from storage I/O control and they're currently used for storage DRS into view, and then your recompose taking into account the I/O and the performance of the individual bits of storage, then that will be a good thing for a recompose. So hopefully that's a feature that guys are working on. Kind of covered that. So again, we're talking, use exactly the same method, right? So get some measurement of the data stores, and then we'll move stuff about according to where it is. Storage vMotion. There is enhancements. So it used to be that there were serial moves. Yeah, if you had disks on a single VM, it would move them serially. You can now do them parallel. Used to be that they did difference, yeah? So you move as much as you can. What's the difference? You move the difference, blah, blah, blah. Now it uses mirroring. So instead of having to do that diff move every time, now instead it mirrors the writes as it's being moved. And so it's much more efficient. For speed, whether it's more efficient for using up your storage resources is another question, but it's definitely faster. So it means that migrations can be done in a single copy rather than like many, many copies. As I said, used to be that your VMDKs were moved one after the other. Now you can move up to 4 in parallel. So again, nice and fast. There are that's one I wanted. SSD monitoring. So if you have SSDs, vSphere is now much better at being intelligent around an SSD. It didn't used to be. So it now uses the smart toolset, which is for SSDs, and your wear out indicators and other stuff, other metrics which are important to SSDs are now covered by vSphere. So you can gather in what you need to do if you have SSDs. And if you run in VDI, then SSD is much more likely, right? So good for us. You can provide plugins, but I've never seen anybody do that yet. Exciting SSD information, particularly the wear out indicator. So you can at least have alerting on when your SSDs are failing now rather than trying to guess. Sparse disks. This is my favorite bit. Sparse disks are very cool. This is another thing, hopefully, that Citrix will be able to take advantage of. Ken. Why are sparse disks very cool? If you have a Delta file, eventually it will grow to the same size as your original golden image, right? How quickly it grows is a factor of the workload that's put onto it. I don't know, is anybody old enough to remember when there used to be profile solutions that were based on mandatory profile and then did a delta? All of those went away because when you do deltas, yeah, it just grows to the same size as the original over time. And so it didn't work for profiles. And the same problem exists whether you're using PBS, MCS, or link clones, is that your delta files will eventually grow to the same size as your disk. Interestingly, it's your disk, not the size of the data on the disk, right? Because this is a problem with NTFS, because as you delete stuff from NTFS, it doesn't mark it as deleted. So what space-efficient sparse virtual disks do is it means that essentially it can reclaim this space, and you will not any longer grow to the size of your disk. You will now just grow to the size of your data. So if you've got a 40 gig disk with 20 gigs of data on, your now maximum size of your delta is 20 gig, not 40 gig. So again, if you have got cool storage, SSD-based storage where space is a big issue, very important for you guys. So I like Sparse Disks for VDI, extremely good. In fact, in Vue, this is the default. Now, so when we talk about NTFS, so this is what blocks look like to your storage for a valid file. This is what blocks look like to your storage for a deleted file. There is no way that your storage knows that that data is no longer valid, because there is nothing to tell it to do so. It's just still blocks of data. In NTFS, it's been marked as able to be overwritten, right? So what's the difference between shift delete and delete? Right? Shift delete leaves the data there, but enables it to be overwritten, and delete just moves folder. Right? There isn't anything in Windows that you can do to get rid of these blocks natively. There is a tool called sdelete, which is written by our favorite guy, Mark Rusinovich, part of the sysinternals tool set. Sdelete stands for secure delete. So don't run it without any switches, otherwise you might lose your OS. sdelete/z will zero out the free space, so it will take account of all of this, all these blocks which are no longer valid files, and it will zero them out, and you can reclaim space. And all the SD Sparse Disk does is exactly the same thing, but it does it automatically without you having to fuck about with sdelete and schedule tasks and stuff like that. So essentially how it does it is it issues a wipe to zero out those blocks and then a shrink. Now, these are quite resource-intensive actions. So this is not a real-time thing. And in fact, it's an out-of-hours thing. So you can pick it to run overnight or whatever, but it's not a real-time thing. It'd be nice if it was, but it's too resource-intensive to be a real-time thing. So you initiate the wipe, searches the file system for unused space, then issues the SCSI unmap, reorganizes the disk, and you end up with less space taken on your SAN. Shrinks it. Cool. Only possible with Vue 5.2 on vSphere 5.1. Nothing else. You can't do it for servers yet. You can't do it for anything at all. Just Vue 5.2 on vSphere 5.1. But as I say, it is the default for Vue 5.2. That's where you configure it, and you can see that it's got blackout times, So you say, do not run this during working hours. You're in a bit of trouble if you've got a 24/7 environment, but it's at least something that we should. If you've got a Vue 5.2, you should definitely be doing this. We talked about sdelete, that's fine. You can do it manually, right? So I do this with some of my customers, is that you group policy preferences, random start for sdelete and schedule it overnight if they've got space issues.
Does sdelete differ for physical or spinning disk versus magnetic media versus SSD?
No, and in fact, yes, sorry? Yes, does, thank you very much. If somebody asks me a question and I forget to repeat it back on the mic, it looks really odd on the recording, and you just hear an answer to a bit of silence. So does sdelete work for physical OS the same as it does for virtualized? Yes, it does. It works inside the Windows OS. It's not a virtual tool at all. It's a Windows tool.
Sorry, question was magnetic versus SSD.
Magnetic versus SSD. I mean, who cares? You got loads of space on magnetic, right? You don't need to reclaim it, but I should think so.
Okay, so it's not secure. It's not about zeroing out. It's not about.
So S delete, yeah, you can run it with loads of flags. So if you just run it, it will garble. It will put random data in every single block, yeah. So it's only running it with a /z argument that cleans out the space. Also, need hardware version 9. Yeah, so you got to have the right version on your VM. So if you move it in from an earlier version, it won't work.
If you're upgrading an existing pool
Yep.
that had hardware version 7 and you brought it all the way up from View 5.0, is upgrading your golden image to hardware version 9, upgrading to View 5.2, is that enough to enable Sparse Disks?
Yes.
To recreate or anything like that?
No, that should just enable it when you recreate your pool,
Okay,
right?
So you don't have to recreate the golden image or anything?
As long as it's hardware version 9, you should be okay. You can test this without having View or anything. As long as you've got vSphere 5.1, you can muck about with this. VMKFS tools, you can create these kind of sparse disks using the command line and then attach them to a VM, and you can, have a play. Now, obviously, the unmap, the wipe, and the shrink aren't available in the same way, but it is available in the new vCenter web console. You can actually give it commands to the in the URL. You've got specific URLs, and it will issue the shrink and the wipe and the shrink functions. And if you cat the VMDK, you can see that it's an SE sparse file. So if you've made one using the command line, you can just apply it using the web client, and you can see that you'll get the type flex SE. So anybody who doesn't have a View 5.2 environment and wants to play about with sparse files, that's how you do it. vFlash. So vFlash is VMware's attempt to solve storage problems by allowing flash as a tier on the host. Very cool idea. It's not been released. It got announced a long time ago. It's not been released yet. I don't know when it's coming out, but it would be very nice if it came out soon. So, in conclusion, increasing the file share limit on VMFS-5 from 8 to 32 means we get bigger clusters, better scalability with VDI. View desks are much more space efficient using SE sparse disks, so great for SSD and other solutions. So more monitoring, troubleshooting, and you can get storage IO control, again, very nice, and storage DRS. So that's all the new features in vSphere 5.1 for storage that I think are relevant for VDI. Now we've run out of features.
How about the storage accelerator that came out in View 5.0?
So,
what's the real life impact of enabling?
so View Storage Accelerator, what used to be called CBRC, content-based read cache. The clue is in the name, read. Yeah, it is a static read cache. Static read caches are the absolute easiest to implement. Your SAN's got one. Yeah, your PVS, your provisioning server's got one. Yeah, fine. For boots, great. It will help. Yeah, but for anything else, it's not going to give you any help. It takes 2 gig of RAM out of the host. Yeah, so yeah, and it's updated, I think, on a 24-hourly basis. Yeah, it's good for boots, but VDI is 80% right. It's a read cache. Yeah, I mean, it's the same for like NetApp's flash cache. It's a read cache. It's going to help with boots and some application openers. Same with your PVS provisioning server. Yeah, it's a read cache. It's going to help with boots and application opens. Right? But the majority of the time, when you've got that 80% right in VDI, it's not going to help. Any other questions? That was a question about View Storage Accelerator. There you go. Any other questions, guys? No. Excellent. So please remember to fill out your feedback forms. I hope it's been useful. I hope it's been what you were looking for. So thanks very much for coming, guys.